Hello friends, today we are going to explain the bond moment and group moment. Also focus on the application of measurement of the dipole moment. Friends, consider the non-polar covalent compound. That is example is S2 molecule. In this molecule, the electronegativity of each hydrogen is same. Therefore, the sharing pair of electron between the bond is equally and distribution of electron in the bond is also equally. Therefore, dipole moment of these molecules is 0. In case of ionic compound, the one electron coming from sodium to fluorine. Therefore, sodium carry plus charge and fluorine carry minus charge. The electrostatic force of attraction between the sodium plus and fluorine minus is called as ionic bond. In case of polar covalent compound, the electronegativity difference between the two atoms, hydrogen and fluorine, is more. Fluorine is more electronegative than hydrogen. Therefore, fluorine carry minus charge and hydrogen carry plus charge. Because the bonding electron clouds is denser around the fluorine as compared to hydrogen atoms. Hence, the bond between two dissimilar atoms are linked by covalent bond. The bonding electrons are unequally attracted due to difference in the electronegativity of the two atoms, like in case of SF molecules. Therefore, the polarity of the bond is arises, and such a polarity are measured in terms of bond moment. The expected or calculated dipole moment of a molecule is the resultant vectorial sum of the individual bond moment. This is the example of benzene. Due to resonance, the benzene show different types of structures. The benzene, naphthalene, anthracene, in these molecules, the dipole moment are 0 or very small one. Hence, all molecules have pyramidal geometry and pack the center of symmetry. In general, all such molecules are planar. Friends, then one of the hydrogen on the benzene ring is replaced by another groups. Then the moment is produced. Now such a moment is called as group moment. मतलब दोस्तों बेंजीन नॉन पोलर कंपाउंड है. अगर एक हाइड्रोजन हमने रिप्लेस किया दूसरे ग्रुप से तो ये कंपाउंड पोलर बन जाता है. हाउ उस मोमेंट को हम ग्रुप मोमेंट कहते हैं दोस्तों. इट इज अ वेक्टर क्वांटिटी. दोस्तों लगभग ग्रुप मोमेंट और बॉन्ड मोमेंट ये सेम होता है. In case of multi-substituted benzene derivative, if U1 and U2 are the group moment of two different substituents on the benzene and phi is an angle between them, the total dipole moment are determined by following formula. That is, U equal to under root of U1 square plus U2 square plus twice U1 U2 cos theta. The study of structure of the molecule with the help of dipole moment. The molecule having symmetry, then dipole moment is less. The more symmetry gives less dipole moment. Therefore, dipole moment are measure the electrical dissymmetry of the molecules and thus help us to understanding the geometry of the molecules. The application of the measurement of the dipole moment give number of application. That is the dipole moment is useful for determine the percentage of the ionic character. Dipole moment is also useful to determine the position of substituent on aromatic ring or also determine bond angle between this substituent or group moment of the substituent or bond moment of the bond in various polar compound. It is also useful for the study of the geometry of the molecules. It is also useful for the study of the cis and trans geometry of an organic compound. It is also useful for determine the linearity and non-linearity of triatomic molecule, such as AX3, carbon dioxide, H2O, sulfur dioxide. It is also useful for determine the planarity and non-planarity of tetratomic molecules, that is the BF3 and NF3. Friends, first I will focus on the percentage of the ionic character. It is determined by U observed upon U ionic, means dipole moment observed upon calculated dipole moment, and we know that the calculated dipole moment is determined by the product of the charge and length and multiply by these terms by 100, that gives percentage of the ionic character. If percentage of the ionic character is more than 50%, then such a compound is ionic compound. Less than 50%, that is a covalent compound. The dipole moment of chlorobenzene is 1.549 dB. If the bond distance of cis bond is 2.8 angstrom, estimate the ionic character of the bond. The given E equal to 4.8 into 10 raised to minus 10 electrostatic unit, that is electrical charge. Therefore, you observe that is given 1.549 dB. The length is also given, that is 2.8 angstrom. The angstrom converted into percent into centimeter. Therefore, multiply by 10 raised to minus 8. Therefore, 2.8 angstrom equal to 2.8 into 10 raised to minus 8 centimeters. Then charge, that is nothing but denoted by E or Q, equal to 4.8 into 10 raised to minus 10 ESU. First calculate the calculated dipole moment, that is Q into L. Therefore, 2.8 into 4.8, and putting this value in our equation, and this equation becomes 1.549 upon 2.8 into 4.8, that gives 11.5 percentage. Therefore, such a compound having 11.5 percentage of ionic character. Now, second application, determine the position of substituent on aromatic rings, or either determine the bond angle, group moment in a various polar compound. In case of the 1 to the di-ortho substituted compound, therefore the moment is determined by resultant vectorial formula under root of u1 square plus u2 square plus twice u1 u2 cos theta. If two substituents are present at the ortho position, then theta equal to 60 degree and cos 60 equal to 1 upon 2. And these two substituents are the same. Therefore, u1 equal to u2. Then our equation becomes u equal to, in the bracket, u1 square plus u2 square plus twice u1 u2 twice u1 u1 1 upon 2 bracket raised to 1 upon 2. Therefore, solve to gives u1 under root of 3. Therefore, the dipole moment of the compound is equal to root 3 times of the group moment if substituents are the same and present at the ortho position. Friends, if substituents are present at the meta position, therefore the angle between meta substituted groups is equal to 120. Therefore, cos 120 equal to minus 1/2. Putting this value in our equation, the equation becomes under root of u1 square plus u1 square plus twice u1 into minus half, that is equal to u1. Therefore, in case of meta substituted benzene ring, the dipole moment is equal to group moment. In case of para substituted benzene ring, the para substituted benzene ring having center of symmetry as well as plane of symmetry. Therefore, dipole moment is calculated by same formula, but theta equal to 180. Therefore, cos 180 equal to minus half. Putting value in the equation, therefore gives dipole moment equal to 0. Hence, at para substituted dibenzene ring, the dipole moment equal to 0. Friends, to solve the problems on the basis of dipole moment. The dipole moment of water is 1.84 dB, while OH bond moment is 1.5 dB. Hence, calculate the SOH bond angle in the water molecules. The bond moment is given. Water containing similar kind of bond, that is OH. There are two types of OH bond. Therefore, U1 equal to U2 equal to 1.5 dB. And total dipole moment of the water is given 1.84. So, by using vectorial formula, U equal to under root of U1 square plus U2 square plus twice U1 U2 cos theta. Putting the value of U1 U2 in this equation, therefore equation become 1.84 under root of 1.5 square plus 1.5 square plus 2 into 1.5 into cos theta. Therefore, we easily got the value of cos theta, that is 3.3856 minus 4.5 upon 4.5, and gives the value of theta by cos inverse. Therefore, that is equal to 104.3 degree. Therefore, bond angle in the water molecule is equal to 104.3 degree. Now, the compound nitrobenzene has dipole moment 3.80 dB. Estimate the dipole moment of the ortho, meta and para dinitrobenzene. Therefore, the dipole moment of the nitrobenzene 3.80, that is group moment of nitrobenzene, that is also same 3.8 dB. At ortho position, we know that the relationship is obtained between the dipole moment and group moment, that equal to U equal to U1 under root of 3. The putting the value of U1, therefore U1 equal to 3.8. 3.8 into root of 3, that gives 6.58 dB. Similar at meta position, the dipole moment is equal to group moment. Therefore at meta position, the dipole moment is equal to similar, that is 3.8. At the para position, having more center of symmetry and plane of symmetry, therefore dipole moment equal to 0. Now focus on the geometry of the molecules. The first point, to determine the cis and trans geometry of an organic compound, that it considers a structure of the fumaric acid, and it is a structure of the malic acid. In fumaric acid, the two COS group are present and trans to each other. In malic acid, the two COS group are present cis to each other. Now, if dipole moment is equal to 0, therefore it is a trans geometry, because the trans, that is fumaric acid, having center of symmetry as well plane of symmetry. If compound having center of symmetry, then it becomes 0 dipole moment. But malic acid not having center of symmetry, therefore dipole moment of the malic acid not equal to 0. If dipole moment equal to 0, therefore geometry is trans. If dipole moment not equal to 0, therefore geometry is trans. With the help of this terminology, you can easily assign the geometry at the cis and trans fashion of an organic compounds. Now, determine the linearity and non-linearity of triatomic molecules. Friends, triatomic molecules means the molecule containing 3 atoms, may be similar or different. Consider the first example, carbon dioxide molecules. There are two possible geometry. One is non-linear geometry, other is linear geometry. The dipole moment of the carbon dioxide molecule is 0. Therefore, this molecule having center of symmetry, and center of symmetry is possible only in linear geometry. Therefore, structure of the carbon dioxide molecule is a linear. Now, focus on the second molecules, that is H2O. In this case, same, the dipole moment not equal to 0. Therefore, geometry is non-linear. Similarly, for sulfur dioxide molecules, dipole moment not equal to 0. Therefore, it is also non-linear molecules. Therefore, structure of the H2 molecule like this way, and structure of the sulfur dioxide molecule as it is. Now, the third application, determine the planarity and non-planarity of tetratomic molecules. That is the types of AX3. The first example of tetratomic molecule is BF3. The structure of the BF3 are present either planar form or in the pyramidal shape. If dipole moment is equal to 0, the structure is planar. If dipole moment not equal to 0, the structure is pyramidal. The dipole of the BF3 is equal to 0. The structure of the BF3 is in planar form. Now second tetratomic molecule NF3. In these molecules, the nitrogen are present, NF3 are present in the planar form or non-planar form. The dipole moment not equal to 0. Therefore, this compound are present in the non-planar form, that is the pyramidal forms. Thank you so much, friend. In the next lecture, I will start the second part of this topic, that is the spectroscopy.